Hello, this is GPIO, and here's another demonstration video. This video kind of follows after the last video, and altogether these videos will be included in a series that I'm going to roughly call PetaLinux. And essentially it's just me learning how to apply PetaLinux and just learning Linux in general, and how I can mix that using the Zynq chip here with some FPGA stuff. So in this demonstration, the only thing the project can do is utilize push buttons, slide switches, and of course also the LEDs. So what I'm showing here is pretty much all it can do. But to accomplish this, well, actually there's one last thing I want to point out. I have a Zyba board connected to the computer, and right now, as you can see there, that's actually output from the application running on the Linux kernel. So if I turn off all the slide switches, of course, that value goes down to 0. And if I start pressing the push buttons, as you can see, the push button values, in case you haven't realized, BBS is push buttons, SWS is slide switches. Now those values change, and everything's base 10. On the right there where it says outs, those are the values that go to the LEDs. And that's basically all the project can do. But to accomplish that, and the reason why I did this project is so that I can learn how to do some basic input and output, and also learn how to use the interrupts. However, to use the interrupts, that basically is dependent on the driver that you're using within Linux. And I'm just using the GPIO SysFs driver. I'm not sure how you're supposed to pronounce that. It's SYSFS. And essentially, well, before I get there, let me just briefly speak about the FPGA stuff. On the FPGA side, nothing at all complicated. It's actually a very simple design, something that you can throw together in a few minutes. But first we have the processing system. There's our GPIO. That connects the LEDs in one channel, and in the second channel we have the push buttons and the slide switches coming in. I'm going to briefly speak about this later, but I also have another constant value that's just equal to 1 that goes into the GPIO block as well. And of course, another important thing is I have the interrupt coming out of the GPIO. That's not it. That's it. I have a single interrupt coming from the GPIO, and it goes into the processing system. Luckily, since I only have one interrupt going in, I didn't have to really change anything in the device. What's it called? The device tree? Yeah, I think it's called the device tree. I believe once I start adding more blocks, I might have to go in and actually change the interrupts there, but after doing tons of reading on the basics of how Linux is applied to an ARM processing system, namely how to understand the device system tree, I think it's called, I know in the future I might have to go there and actually configure the interrupts properly, but in this case I checked it and it's definitely connected right, plus the application works, so it shows that the interrupts are working as intended. But moving on to the actual application itself, I'm actually going to probably write a blog about this. I do plan on posting this application on my GitHub, but essentially, like I said before, I'm using the GPIO SysFs library or driver to basically drive the GPIO from a regular user application that of course runs on user space on the Linux operating system. So that's basically what the code is, and this is like the main function here. So within this function that I wrote, pull GPIO value, and this is where most time I spent doing this particular project. I had a hard time trying to use the pull function, and when you're using the GPIO SysFs, if you look at the documentation of the Linux for the GPIO driver, it basically says if you want to use the interrupt, you can actually configure the driver by setting the edge file for your particular GPIO to rising or to whatever state you want the interrupt. And then you can use the pull2 function to actually pull on it. So I'm assuming if you have a larger application, you would create a thread that would just pull on that particular pin. And I'm assuming, I didn't actually check this using a logic analyzer, but I'm assuming by polling, it actually just waits on that interrupt, and then when it triggers, it's up to you to go and check the state of the GPIO pin. One weird thing that I ran into is if you don't, at least in this case, I couldn't figure out another way of doing this, but after looking up a few things online, I found out if you don't go and do a dummy read before you poll, like specifically, here's my polling function right here. So it says I have a read function here, which this doesn't do anything but just read. Like, I don't actually save the value to anywhere. But to get this poll function here to work, which is necessary if you want to use the interrupt, you know, I had to call this read function. But it seems like a waste, because I'm assuming if I call that read function on that file descriptor, file values where you actually get the value for the pin, if I call it, I'm assuming it's actually reading from the AXI, which could potentially tie up the bus. But if I do that, then the poll function works as intended. If I don't call the read function, it just breaks immediately, which is not what the poll function is supposed to do. So that was one tricky part. Another thing that I realized that caused me to have not a huge problem was that for whatever reason, and I still couldn't figure this out, but I want to move on to another project, but for whatever reason, I basically need to have one pin always high for the interrupt to work properly. Don't understand that. Might look into it later, but I want to move on to bigger and better things. But that's just a small thing that I had to do to get things working. But yeah, this basically concludes it for this video. This video actually has gone on for a while, but had a good time learning this project, and I look forward to doing more interesting things. Next up, I might do some audio processing in Linux. I have plans to try to learn how to use the SPI driver, and then also learn how to use the I2C driver. Both of those things are necessary if you want to read from a microphone. I'm planning to use a microphone that connects to one of the PMODs, basically the same one I've been using in like every other project. But I'm also going to be using the audio codec on the Zynq, which I've used before in the past, but I've done so only in a bare metal type operating system. And I have a few other things, but in an effort to try to keep this video as short as possible, I'm going to cut it off here. Thanks to those who took the time to watch this, and goodbye.